Okay, welcome again to another tutorial. Today we are going to discuss ways of representing errors. As you see, errors can be represented into three ways. The first one is absolute error. The second one is fractional or relative error, as you see here. The third one is percentage error. We are going to begin with absolute error. By definition, absolute error is algebraic difference between the exact value and the measured value. Algebraic difference between the exact value and the measured value, that's known as absolute error. For example, a measured value is 7.9 meter. This is a measured value, and exact value or true values is between 7.85 meter and 7.9 meter, 7.95 meter. When you observe here, when you consider this first exact value, which is 7.95 meter, the difference between 7.9 meter, which is measured value, and this 7.85 meter, which is exact value or true value, there is a difference of 0.05. It means this 0.05 is an error. It means measured value is more by 0.05 meter from our true value or exact value, which is 7.85 meter. In order to obtain exact value, which is 7.85, meter, we have to subtract this one 0.05 meter from our measured value, which is 7.9 meter. That's why we put a negative sign here, like this one. So when you subtract this 0.05 meter, which is the difference between these two, when you subtract it from measured value, which is 7.9 meter, when you subtract 0.05 meter, you will obtain this exact value or true value, which is 7.85 meter. Okay, now consider this second exact value and true value, which is 7.95 meter, and our measured value is 7.9 meter. The difference between this one and this one also is 0.05 meter. 0.05 meter. When you observe here, this exact value is greater than measured value by 0.05 meter. So it means in order to obtain this true value or exact value, we must add 0.05 meter to the measured value. That's why we put a addition sign like this one. So it means this one is known as an absolute error. In order to obtain absolute error, you can add or subtract to the measured value. That value which can be added or subtracted from measured value is known as absolute error. So this is known as the absolute error. That's why we say absolute error is the algebraic difference between exact value and the measured value. I hope you have understood what is absolute error. Okay, in measurement, for those instruments which are used to measure different physical quantity in physics, their absolute error is taken to be half of the value of the smallest unit or division. I will repeat again. For all instruments, the absolute error is taken to be half of the smallest unit or division. For example, the stopwatch. the smallest unit or division of the stopwatch is second, or a second, 1 second. The half of this smallest unit of a stopwatch is 0.5 sec. So it means this is the absolute error for a stopwatch. So it means to write it clear, we will put positive and negative 0.5 second. So this is an absolute error of a stopwatch. Another example, in order to determine absolute error of the instrument, consider a meter rule. The smallest division of a meter rule is millimeter, 1 millimeter. A meter rule, a rule like this one, has 1 meter, and we know from here is 0 centimeter, here is another centimeter, 1 centimeter, here is the second centimeter, up 30 centimeter, up to 100 centimeter, which is equivalent to 1 meter. But from 1 centimeter to another, there is a 10 divisions. There is a 10 division. We know 1 centimeter is equivalent to 10 millimeters. So it means from here up to here there is 10 millimeters. And in this one division, here between 0 and 1 centimeter, it is 0.1 centimeter. But 0.1 centimeter is equal to 1 millimeter. That's why we say the smallest division of a meter rule, which is equal to 1 millimeter, as you see in this example. In order to obtain an absolute error in a meter rule, we said you take a half value of the smallest division. The value of the smallest division in a meter rule is 1 millimeter. So it's a half, it will be 0.5 millimeter. So this is an absolute error in a meter rule, or can be written as plus or minus. You can add or you can subtract 0.5 millimeter. So this is a way of obtaining an absolute error from different measuring instruments. Okay, we are going to discuss the second way of representing error, which known as fractional error. Fractional error is the second way of representing error. Errors can be expressed in fractions. You know, a fraction is written in form of a over b, so it means error can be expressed in this form. So a physical relation to express error in a fractional error is written by taking absolute error divided with actual value or true value, So this is a simple physical relation to write or to express an error in a fractional error, or in other name, as I said, we call it relative error. For example, you have an error, you have a physical quantity of length. For example, the length of a stick is 7 meters. This is true value. When you write together with its absolute error, can be written like this one, plus or minus. As I said, to write an absolute error, we plus or we subtract. So absolute error is 0.2. So the unit used maybe is centimeter. So this is true value or actual value, and this one is absolute error. So in order to find the fractional error, we take absolute error as this formula. You see this formula. You take absolute error divided with the actual or true value. In this example, which is the length of our sticky, which is written together with its absolute error, which is 7 plus or minus 0.2 centimeter. To find the fractional error, I said you take absolute error divided with actual or true value. So it will be 0.2 divided with 7. So here you will obtain fractional error, which is equal to, when you multiply with 10 up and down, it will be 2/70. When you simplify, it will be 1/35. So our fractional error in this example of length of a sticky is 1.35. Simple like that one. This is a fractional error. I hope you have understood. Let us finish the last way of expressing errors, which known as percentage error. In percentage error, we can say is the expression of fractional error in percentage. Or in other words, I can say when you express a fractional error into percentage, that known as percentage error. So a formula to obtain percentage error is equal to absolute error divided with the actual or true value multiply with 100%. When you observe, this one is a fractional error. Absolute error divided with actual value is a fractional error. When you multiply with 100%, it will change and becomes percentage error. So that way we say is an expression of a fractional error in percentage error. In the previous example, we obtained the fractional error of our length 7 plus or minus 0.2 centimeter. The fractional error was 1/35. So when I take this 1/35, as you see here, the fractional error we obtain here, as you see, the fractional error was 1/35. So when you take this fractional error and multiply with 100%, you will obtain percentage error. So it means fractional error was 1/35. Now we take this fractional error and we multiply with 100%. So we'll obtain percentage error, which is equal to, let me take a calculator. So I hope when you do some calculation, you will obtain an answer. So this one is the percentage error. So when you divide here 100 divided with 35, an answer will be expressed in percentage error. So thank you for watching. Welcome in the next tutorial, and don't forget to subscribe in my channel. You are most